So as I mentioned, the DSM is the post-process product that's going to come out, the first return product. That product needs to be edited into our DTM, or our digital terrain model, which would be bare earth. And as well as making that product, there's multiple other edits that our editing facility in Jakarta will utilize our proprietary EIS software to edit, as far as removing the artifacts that could be made from the radar, flattening the water, and manipulating the actual ground with 3D vectors to try and get the best representation of the terrain. So using this software, the editors actually have a two-monitor system that they're utilizing. And the monitor on the left that you can see that's showing the ORI, that's actually a 3D environment for the editors. And it utilizes the ORI in a 3D representation using the terrain that have been collected, so that the editors are actually seeing all the vegetation, man-made features popping out of their screen while they're editing it. At the same time, on the right-hand monitor, they have access to all sorts of ancillary data that helps guide them. The ancillary data is tied directly to their left-hand view. So as they pan around, the ancillary data pans with them, and they're able to validate what they're seeing in their 3D environment with either aerial photography, topo maps, or other available terrain data that might help them to best understand what they're editing. So as I mentioned, part of this editing process is removing the artifacts from the radar sensor. A radar, like any other sort of remote sensing device, is going to have some sort of anomalies that come back, returns that aren't true, and reflections that show up strange. So the editors are well trained in identifying these and cleaning them out, as well as the water bodies, being that terrain models are often used in hydrologic applications. It's important that we make all the waterways and water bodies look as clean as possible. So the big part of edit, and where the most time is really spent, is this transition I was talking about earlier of DSM to DTM, where we're taking the first return model that has all the cultural features and vegetation, treetops, things like that, and getting that to a bare earth model. Again, for hydrologic purposes, this is very important because trees and buildings, though they show up as obstructions in a terrain model, are not much of obstructions for water. So it's important that they get removed so that any sort of flood models or any sort of ground survey work that you're wanting to do, you're getting the best representation of the ground. Now, when the editors are actually doing these edits, what they're doing is classifying pixels within our data set. And so they've got numbers of classifications that they can utilize. The three that I'm showing here are the main ones that the editors will be using to actually create the DTM from the DSM. So the green areas that you see sort of isolated around this image are what are defined as not bald, meaning areas that have a individual obstruction, be it a telephone pole, a house, a small area of trees, things that the software can easily identify all the elevation points around that obstruction and interpolate the surface and remove the obstruction. The area underneath that, that's shown in pink down here, is the bald classification. And so the editors will actually draw a representation of all the areas that their ancillary data is pointing to and that they can interpret from what they're looking at in their 3D environment as flat, bald earth ground. And so those all get classified in this purple color. And then the final classification that is utilized for the DSM to DTM edit is the prefit classification. And this is an important classification because this is how we deal with heavy canopy, heavy urban areas that we can't see ground points. And what prefits does, FIT stands for Fully Integrated Terrain System. And when the editor classifies that, it basically means that the software is going to do its best to interpolate ground points within that area, find ground points, and then remove that data that's remaining. And the editors then have access to ancillary terrain data that they can either then utilize our proprietary data fusion process as part of the EIS editing system, or they can utilize a series of vector sort of break lines, soft break lines that they're able to pull from ancillary data to build a terrain surface under these obstructed areas. So there's a number of methods that are utilized for this, and I won't get into everything here as far as what's happening, but basically when it's classified as prefits where we have large obstructed tree canopies, like this area you can see here being a tree canopy, notice how the editor leaves areas around that are the bare earth. Those are going to act as the ground points that we're going to tie any ancillary data that we're putting into this, or as we build break line models based off the heights measured from the canopy and how that canopy is representing the actual terrain below. So there's a science that they're utilizing to basically give us the best representation of the ground below it without the radar actually doing full penetration of the canopy. So just to give you a little example of what the editing classification would look like, on the left down there is the editor's screen as they're looking at it. They classify all those areas as not bald, and then the EIS system does its interpolation, running a basically cutting algorithm that cleans out all those obstructions and gives an interpolated ground surface.